So guys, welcome to our channel once again. In today's video, we have here these 10 questions to answer on the topic gravitational field. So in short to set you at the end of this video, we have here the first question, which says two bodies of mass 3 kg and 2 kg are separated by a distance of 50 cm. Calculate the force of attraction between them. So guys, the gravitational force here can be calculated as F is equal to G into M1 times M2 over R squared. So guys, the G is already given here as a constant here. So you can see 6.67 times 10 to the power of negative 11. Then these times M1 is 3. So you multiply this by 3, and then M2 is 2. You also multiply by 2. Then over the R squared, which is the distance between them. So guys, take note that R squared here is in cm, that's 50 cm. So if you convert this to the standard unit, meters, you'll have 0.5 meters. So guys, we'll go ahead and calculate all these. We'll have 1.6 times 10 to the power of negative 9, and that's option A here. So option A is the answer to this question. Let's go ahead and consider the next question, guys. So the next question we have here is question number 2. It says the acceleration due to gravity may be defined as the force A with which the Earth attracts 1 kilogram mass, B the force of attraction of the Sun on the Earth, C the force of attraction of the Moon on the Earth, D the force of attraction with which the Earth revolves around the Sun. So guys, the answer to this question is option A. The acceleration due to gravity can be defined as the force with which the Earth attracts 1 kilogram mass. So that's it for this question. Let's go ahead and consider the next question, guys. So the next question here says, a planet has mass m and radius r. If the universal gravitational constant is g, what is the expression for the escape velocity of an object on the planet? So guys, this is just as simple as this. The escape velocity v sub e is going to be square root of 2 gm over r. So guys, now if we express this its relation to the options we have here, the option that will suit this is 2 gm over r in parentheses to the power of 1 over 2. So the answer to this question here will be option B, and that's it for this question. So let's go ahead and consider the next question. So guys, the next question here, question number 4, says a rocket is launched from the surface of the Earth. If the radius of the Earth is 4.6 times 10 to the power of 6 m, and the acceleration of free fall due to gravity is 10 meters per second squared, calculate the escape velocity of the rocket. So guys, in order to do this, you're going to use the formula square root of 2gr. So here we're going to have 2 times 10 times 4.6 times 10 to the power of 6. So guys, when we multiply this out, we're going to have 9.6 times 10 to the power of 3, and that's it for this question. So let's check out the next question here. Question number 5 here, it says two objects P and Q of masses 100 grams and 20 grams respectively are 1.2 meters apart on a horizontal surface. Calculate the net gravitational force. So guys, Fg here is going to be G into M1 times M2 over R squared. So M1 here is 100 kilograms Then what's the gravitational constant? That's 6.67 times 10 to the power of negative 11. So this will be multiplied by the mass 1, which is 100, times the mass 2, which is 20, then all over the square of the distance between them, the square of 1.2 meters. So guys, when we go ahead and calculate this out, we're going to have 9.26 times 10 to the power of negative 8, and that's option C here. So that's the answer to this question. Let's go ahead and consider the next question, guys. So the next question here is question number 6. It says, the magnitude of the gravitational force between two particles 0.1 m apart is 10 newtons. If the distance between them is increased to 0.2 m, calculate the magnitude of the new force. So guys, we're going to use that F1 R1 squared is equal to F2 R2 squared. So F1 here is the first force, which is 10 newtons, then times R1, which is R1 squared, which is 0.1 squared. Now this will be equal to F2, which is not given, so we'll write that as F2 as still, then times R2 squared, which is 0.2 squared. So guys, in order to get F2 now, we'll make it the subject of this equation, where F2 becomes F1 R1, which is 10 times 0.1 squared over R2 squared, which is 0.2 squared. So guys, when we go ahead and calculate this, we'll have 2.5 newtons, and that's it for this question. So let's go ahead and consider the next question, guys. So guys, the next question here is question number 7. It says, the Earth is not a perfect sphere because its equatorial axis is longer than the polar axis. Where on the Earth's surface would an object have its greatest weight? So we have A, at either pole, B, near the equator, C, halfway between the equator and the North Pole, and Z, halfway between the equator and the South Pole. So guys, the answer to this question is option A, at either poles. So let's go ahead and consider the next question. So that's question number 88. Says, the mass of the Earth is 6.0 times 10 to the power of 24 kg, and that of the moon is 7.0 times 10 to the power of 22 kg. If the distance between them is 4.0 times 10 to the power of 8 meters, calculate the force of attraction between them. So guys, the force of attraction between them, which is the gravitational force Fg, is going to be G into M1, or in this case, let's say ME times MM, that's the mass of Earth times mass of Moon, then over R squared, which is the square of the distance between them. So guys, if we go ahead and plug in the values here, we have that Fg is equal to G now is 6.7 times 10 to the power of negative 11, and this will be multiplied by the mass of the Earth, which is 6.0 times 10 to the power of 24, then multiplied by the mass of the Moon, which is 7.0 times 10 to the power of 22, and all this over the square of the distance between them, that's square of 4.0 times 10 to the power of 8. So guys, we'll go ahead and calculate this all through. So that's option A here. So option A is the answer to this question. So guys, let's go ahead and consider the next question. So the next question here is question number 9 here. It says, an object is dropped from the top of a tower. If it takes 4 seconds for it to reach the ground, calculate the height of the tower. So guys, let's use the formula. T, which is period, is equal to square root of 2h over g. So guys, if we remove this square root by squaring both sides, we are going to have t squared is equal to 2h over g. So if we go ahead and plug in the values here, t, which is the period, is 4 seconds. So 4 squared is equal to 2 times h over 10 meter per second squared. So guys, to find h now, we're going to do 2h is equal to 4 squared times 10. 4 squared is 16, then times 10 is 160. So 2h is equal to 160, and then h is equal to 160 over 2, which is 80 meters. So the height of the tower is 80 meters, and option B is the answer to this question. So let's go ahead and consider the next question, guys, and that's the last. So guys, the question here says, given that the gravitational constant is g, Newton's universal law of gravitation states that the force of attraction between two masses m1 and m2 separated by a distance r is a. g into m1 m2 over r squared, b. g into r squared m squared 2, c. g into m1 m2 over r, and d. g into r m1 m2. So guys, obviously the answer to this question is option A, g into m1 m2 over r squared. So that's the Newton's universal law of gravitation, and that's the answer to this question, guys. So this is where we'll end this video for today. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below, and we'll ensure to give you a response. So finally, guys, I want to encourage you to join our YouTube channel community. So you can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.